Okay. Hello, everybody, and welcome to my first fellowship lecture, but probably your second or third. Anyway, today I'm going to be talking about Python for data science with Python, and then especially how to visualize geospatial data. First, a little bit about me. My name is Britt van Veggel. I did a bachelor in mathematics at the Radboud University and a master in applied mathematics at the TU Delft, where I specialized in optimization. And I wrote my thesis about flood resilient infrastructure with the ABW Institute. I have some working experiences as a data scientist at the Volksbank and at Tenet and the Question Mark Foundation. And I'm currently a passionate PhD student at Analytics for a Better World. And I'm specializing in geospatial accessibility optimization. So that's what I will be teaching you a little bit about today. So especially visualizing this data. So the things we're going to be talking about today is GeoPandas. We're going to look at what it is, how to work with it, and what the CRS thingy is that you always have to work with in GeoPandas. We're going to look at raster data, on how to load it, how to plot it, how to do calculations with it, and how to combine it with GeoPandas data. And lastly, we're going to have a short look at Folium, look at how to combine it with GeoPandas, and how to extract information from it. And we will continue at a Google Colab notebook, which is the link here, and I will put it in the chat so that everybody can join. Let me know if anything is going wrong. Okay, it's working for me. Okay, I will wait a minute, and then maybe if anybody's having difficulties, I will.
Once you guys have joined the Google Colab, please raise your hand.
Should we make a copy to our own drive? That's what we did yesterday.
I don't think that is necessary, because I think you're getting somewhat of a copy. I think a copy is just being saved in your own Google Drive.
Okay.
Unless you want to save it, of course, which you're allowed to do. But it won't interfere with my notebook here.
Someone would like to know, Britt, what is the cute animals plugin that you're using?
Okay, while we wait, I can quickly show you that. If you go to here, it has a little circle, the settings circle, and then you go at the bottom to miscellaneous, and then you have all these modes that you can choose from. So I will go with just the crab mode today, or do you think that's distracting?
I think it's nice.
It's nice, right?
Are you feeling crabby? Are you not feeling good?
No, I'm feeling good. I'm feeling good. I just want to see little crabby crabs. It will make me feel even better.
Okay, we have about 15 people that have been able to join. Has everyone else, if you're able to join, please raise your hand. Yeah, okay. I think most people have been able to join, so I think we can keep going.
Okay, amazing. So what is going to be the idea of this is that I've prepared a notebook with some explanations and blah, 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 and we're going to go through it together. And you can kind of experiment with the data and see what's going on. So we'll kind of be programming, even though the code has already been programmed. And the nice thing about this is that you will have some code that you can work with and an explanation. and it'll be a bit more interactive. So this first part, I think it's where you do some installations and some imports, and it's not really relevant for us at the moment. So we're just gonna let that run and wait to see it downloading all the packages we need. And these downloads are especially for GeoPandas. So it takes a little while. All right, it's ready. All right, so now we move on to the next cell underneath GeoPandas, download and clean the data. We will be downloading 2 different files, and don't worry, these won't be saved on your computer or not even in your Google Drive. We're just downloading them into the computer that we are borrowing from Google. And it's really neat because the nice thing is when you use GeoPandas and you do .read file, you can input a link that downloads the file here. So you can always automatically download data into your file from the internet. So the 2 files we're gonna download is one that has all the admin boundaries of the Dutch municipalities. That's the first one. And the second one we will download is the road network from Amsterdam. And this code here cleans it up a little bit, is also taking one separate, is making a separate GeoPandas data frame for Amsterdam. And especially because the download of the road network contains a lot of information, we're filtering some of that information out. And what I'm doing here, I will explain a little bit later. And I think the rest is kind of understandable, right? So we take the NL bounds data frame and we just filter out the one where the name of the municipality, or in Dutch de gemeentenaam, is Amsterdam. And we're saving that shape. Yeah, and here we're filtering out like the columns that are either highway, name, bicycle, max speed, or geometry. And here, because in the download it gives you a string, but we want the max speed to be an integer. All right, but the most important part is to look at the next cell. So this is just how our data frame looks, and you're getting these strange warnings. Don't worry about that. If you run the cell again, they disappear. So I've tried to work around this. I don't know exactly why it's happening, but it's nothing to worry about. So anyway, this is our data frame. I think you've all seen a pandas data frame before, right? Yeah, I'm seeing one thumbs up, which is good. Okay, so you have different columns with different information, and then you have different rows, and each row represents a certain representative of your data set that has all these different attributes. So in this case, this is the information of the different municipalities in the Netherlands. We're having a code for the municipality. It has a certain name. And then we see a geometry, which is, and in this case, it says multi-polygon, and it has all these numbers with it. And that is what is the difference between GeoPandas and regular pandas, because in GeoPandas, you always have this geometry that kind of represents the shape of the item you are working with. There are these different things that you have. So you have multi-polygons, you have a normal polygon, you can have a line or just a point. We'll be seeing more of that a little later. But just so you know that this column makes a geodata frame because it contains some shape. So let's have a better look at those geometries. Here I did NL bounds, and I just took one random one. And then I want to look at what the geometry is. And I'll run it twice so we don't get the errors. So we suddenly get the shape. So this is what the municipality of Nijmegen looks like. I took this one separately. I took this one especially because it's the gemeente where I live. But we can just also take another one. So let's look at the 100th municipality. And that's also a strange shape. So we get all these different shapes that represent the geometry. We'll be plotting them all together a little bit later. But next, let's look at our roads data frame. So again, we get something that looks like a data frame with a geometry column. So now we have indexes that represent the OSM ID. So OSM is OpenStreetMap. I think Parvati has talked about this in the lecture, right? So we have OSM IDs. Then we have a highway, which indicates what type of road we're looking at. So we have a cycleway, pedestrian street, a footway, all these different highways. The roads have different names, so they don't all have names, but we have the Vondelpark, we have the Zeeburgstraat, etc., etc. Then we have a column called bicycle, and here we see a few yeses, but mostly nan values. So these are empty columns. This indicates if it is a bicycle, if you can bicycle on this road or not. Then we have a column max speed. Here it's all nons, but we'll see a little later that there are roads that have an indication of the max speed. And then again, we have the geometry. So we see mostly line strings. And to have a look at the line string, I've plotted it in the next one. So we just take one out. It is just a line. And the idea of this line is, let's print it, because then it's easier to see. We get line string and then we get coordinates. And the idea is actually that we have a little list of all these different coordinates, and the line is being drawn from coordinate to coordinate. So here we see a bunch of coordinates, and then if we remove print and we show this line again, we see that it has little bumps in the side, right? So these are all the coordinates that this line is walking along. Is that all clear? All right.
I have a question about it.
Yeah.
So these coordinates, can you see them as longitude and latitude, or is a different coordinate system?
Can I see them as, sorry?
As latitude and longitude, like
yeah.
What does it mean 4.9? Okay.
Yeah. So this now we're working with latitude and longitude. I will get to the latitude and longitude part a little later, because we now have it in latitude and longitude, but there are many different coordinate reference systems that we can work with, and there are different reasons to use different ones. But first, let's go and look at the plotting of the data, and then we'll get into coordinate reference systems. So to plot, so the nice thing about having this geometry column is that it has this shape along with it, and that we can easily plot it. So we plot it we do the data frame and we do dot plot. Oh, now I'm moving something. We do dot plot, and then it just draws all these shapes together, which is really nice. Please give it a try. So now what we see here is the road network of Amsterdam, all in blue lines, plotted together. And here we have the latitude, and here we have the longitude. So for the people that do live in Amsterdam, they might recognize the shape a little bit. There are no roads here because this is where the river goes. And this is that one part of Amsterdam that is a bit isolated with a different city in between. Has everyone plotted it and been a bit amazed by what they've now made? I see a smile, and I think I'll go with that. So, okay, so now we've used the .plot, but we have this big bundle of all these lines, and it's a bit overwhelming, right? So what if we wanted to know, as we've seen here, we have this column highway that has all these different types of roads. What if we wanted to make a distinction between these? Because this is different information, and maybe we want to know when a road is a cycleway and when it is a pedestrian street. So to plot that separately, we can add into this function plot, we can do column is highway. And then we pass along a CMap. CMap is the coloring map, so the different colors that it should use. And we also want to make the picture a bit bigger. So we use fig size is, and then we just set the size of the figure. And then we do legend is true, because we want to have a little legend that shows us which color refers to which type of highway it is. And then again, we do plt.plot, we run the cell, and we get, it takes a little bit because it's a lot of data, but we get this gorgeous image. So again, this is the network of Amsterdam. It's much bigger this time. We see all these different colors. So we see that, let's see, these more orange roads, they are emergency and footway roads. We see here the little green roads, they're proposed or raceway roads. What else do we see here? All this purple, it's all residential roads. These big orange roads here, they're motorway roads. Yeah, so we're already getting a lot of information from this image. Is it working for everybody? Just to have a little check. Yeah, okay, good. All right. So let's play a little bit with these different columns that we can pass along and the different sizes. So now we want to see which roads have a max speed and what this max speed is. So we're plotting two things here, namely, so we have again the column max speed. We have a CMap is cool, warm, and we want our legend. But as we've seen before, some columns don't have information. So these are all these nan values. And sometimes we want to see our nan values, and we wanted to distinguish a little bit between it. So what we can do is add this missing KWDS is, and then we set some information for this. So what I've done in this case is I want the color to be light gray, and the alpha, which is the opacity with which it works, to be 0.25. So the lines will be less, how to call it? They will be a little bit see-through. So that is the first plot. So here we see the first plot. We here see again the different colors that correspond to how fast you can drive. So it's logical, like the big red one, we can drive 130, which is the fastest that you can drive in the Netherlands. And that's because this is the ring, the highway around the city. And then we see some really dark blue here and there where you can only drive 3 kilometers. But we see a lot of these nan values. That's all this gray stuff, and it's making the image a little bit unclear. So it's not always useful to use this missing KWDS, because it can also overwhelm your picture a little bit. So in the next plot, what we're going to do is take out all the roads that do not have a indication of the max speed. So I think you know the dot is null attribute, which tells you which values are null. So wait, let me just show you that to be clear. So here we see that all these first one, they're all all these ones are none. So in this case, it will give a true value. As you can see, true, 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 true. And now if we put this tilde in front of it, it'll give us exactly the opposite. So it will make the values that are true false, and the values that are false true. So this gives us the ones that do have a value and are not null. So here we see it, and we can check up on that by putting these brackets around it and doing roads, AMS. And then we can see it has filtered out all these non-values, and we can see here all the information, and max speed is 15, 30, 70, etc. So that's what we are plotting here. So we're just plotting this data frame where we have the max speed information. We're doing dot plot. We're using the column max speed. We're using the CMAP cool warm that goes from light blue, or that goes from blue to red. So the low values will be blue, the high values will be red. And we want to see that legend again. So this is the second image you're getting. And we can already see there's much less information, and all the roads that are in are colored. So now here we can very clearly see, I mean, this is about where the train station is. And of course, you're not allowed to drive very fast. So this is where we drive 3 kilometers. We can see some of the grayer areas where we can drive a little faster, like 25 or 30 kilometers an hour. And then on the more structured routes, a bit higher. So, so here you can already see how you can go about it with different information. So do we want to make information that we don't have clear, but a bit separate from the image? Or do we want to take that information completely out so we can just have a look at the information that we do have? Is that clear for everybody, how it works? Yeah, all right. Let me know if I'm going too fast or too slow maybe, or if there's something you don't know. All right, so now we've played around with the max speed column. Let's now have a look at the bicycle column. And the bicycle column is a bit messy because you would expect it to contain yes or no. But when we look at the different things that we can find in this column, we found a lot of more information that doesn't seem relevant, like private, the customers, and that's just messy information. So the question arises, what are we going to do with that information? So there are different ways to deal with it, because let's say we just want to know if you can bicycle on a road, yes or no. So there are two ways we can go about it. We can create a new column that also contains the non-values, but that only looks at the rows that are yes or no and attributes true or respectively false to them. So how we do that is here we make a new column. So we just make the new column called bicycle clean, and we say that all the values are none. And then we filter out the values where it is a yes, and we attribute true to that. And here we filter out the columns that are no, and we attribute false to those. And then we can plot our new bicycle clean column. And we can also pass along to the missing information. Again, we make those lines light gray, and we make them a bit see-through. So here we plot that with a look at the bicycle clean, and we just say go from red to green. So if it's false, it will become red, and if it's true, it will become green. And then we attain this image. Here it's plotting. So here we see it. So on these little roads here, we can bike, and on those red roads, we cannot bike. We know that for sure. But all these gray lines, we have no clue if we can bike on them, yes or no. I see somebody's playing with the pen, the annotation thing. Maybe erase it, and then it won't get into the screen of everybody. Okay, but anyway, going back to the bicycle thing, so we've made a new column. It is clean or not, so maybe let's have a little look at how this column looks, just so we're up to date. So it's bicycle clean. Oh. Or maybe just have a look at the whole thing, so then we can see what happened. So here we see that the yeses became true, the nones are still nones, and you have to believe me if I say the other ones are still clear. All right, there's another way to go at it, because what we can also do is plot the same data frame, but filtered multiple times in our figure. So this is what we're going to do here. So what we're going to do in this picture is make 3 different data frames, namely one data frame with where the bicycle value is not no or yes. We're gonna make those lines gray. Then we're gonna add another part of this data frame, which is where you are not allowed to bike. So where bicycle is no, we're going to make those lines red. And then we're going to add, for the 3rd time, where all the values for bicycle are yes, and we're going to make those lines green. So again, as I showed before, we're going to take these slices. So if we look at, for example, the first one, we say we are roads of where bicycle is either yes or no, and we're going to look at the values that don't have that. So in this case here, we see for the bicycle column that it's all nones, or maybe if we do if we look at the first 20 values, we can. Yeah, so for example here, this is the first 20 rows in our data frame. We see that it also contains designated, for example, but a lot of it is none. So that's the first one we're gonna plot, and those are all gonna be gray. Then if we look at the second one here, these are all the ones where the bicycle is no, so these are all no, and then the last one is yes. So these are the 3 different ones that we are going to plot. And in order to plot multiple different data frames into one figure, we use plt.subplots. And we're going to take a figure and an X. And then we can add these 3 different data frames. And again, we do plot, but we need to tell the plot that we're all going to be in that same figure. So in that case, you do AX is AX. See, we've done that here and here and here. And now all these 3 plots are going to be put together in that one figure. Then we tell it for the first one, the color is light gray. For the second one, the color is red. And for the third one, the color is green. And then we can put a label with it. And this will have to do with the legend. So we tell it for the ones that are neither no or yes, that the status is unknown. The second one is going to be red. We tell it these are not bicycle roads. And for the third one, we tell it this is a bicycle road. And then we can add a little title. So we do plt.title, and then we ask ourselves the question, do roads have bicycle lanes? We make sure that our legend is included, and we show the picture, the figure that we've just made. So now we run it, and we see this beautiful image. Pretty cool, right? Is it still working for everybody? Yeah, everybody up to speed? Okay, good. All right. So those are 2 different ways to deal with taking out a bit of information from our figure. So you can either make a whole new column and add them all into the same figure, or you can make different data frames and add them all into the same figure. All right, now I haven't shown you yet, so that's maybe nice to do first. If we combine two different data frames, so we've now looked at this roads data frame, but let's look at the NL bounds. So let's just plot it, see what we have in stock. So we see all these, we see the shape of the Netherlands, and we see all these little figures in it, which are our different municipalities. So now we kind of want to, so Amsterdam is going to be here. We want to see the roads of Amsterdam and our municipalities all together. Oh, and I've also made here Amsterdam, which is just a data frame with one row, namely all the information of Amsterdam. And we can also plot that one. And then we just see this one shape, right? All right, so using the method that we have used here, we do again, we use subplots, we add them both together, and we show the figure, right? So let's do that. But now we're getting this weird figure, because here we see that here is that blue thing that was supposed to be Amsterdam. But we're not seeing the lines, and we're seeing a lot of other information. Very confusing, right? So what has gone wrong here? This has to do with the coordinate reference system that I've talked to you about before. So it seems like the two different sets have a different coordinate reference system, or that might be the issue. So let's have a look at what these different CRSs are. And we can see what the CRS are of our data frames by using the attribute .crs. So I've now here made a little cell where you print both CRSs. So first it prints the CRS of a roads data frame. And next we're plotting the CRS of the Amsterdam data frame. So just containing the municipality of Amsterdam. And we see that they have different numbers. So they're having different coordinate reference systems. So we saw here, if we look at our Amsterdam roads data frame, we see it goes from 52.28 to 52.44, and from 4.75 to 5.05. So now let's have a look how that works for the Amsterdam data frame. We're getting completely different coordinates, right? Because here we're already looking into the hundreds of thousands, and here the same. So this is kind of how those different coordinates work. So it's quite confusing, but it's not confusing to fix it, because we just have to make sure that they have the same CRSs. So what we're going to do in the next cell is we're going to translate the CRS of our Amsterdam data frame to the CRS of our roads data frame. So for that, we're using the command .crs to CRS, and then we just first put the CRS system of the Amsterdam data frame. And when we run just this, and I think as you've worked with Pandas before, you know it will return just a Pandas data frame, but it's not necessarily going to save it, because if we do the next cell, we do Amsterdam. So here we see that our multi-polygon has now this 4.9 something and 52 point something, but then if we run this again, it returns these old coordinates. So to make it save this, there are two ways to do it, but the most pretty one, I think, is adding in place is true. So it's doing it in its place. And then when we look at Amsterdam, we see that it saved these coordinates. Is that clear or a bit confusing? I see one thumbs up, and I'm gonna go with it. Okay. Oh yeah, of course.
Yeah. So the in place is true. You can use it in general data frames to kind of replace the existing data frame.
Yeah,
or
True.
specific to the CRS function?
Well, it works for the CRS function, but it works with more functions that you can use for data frames. Usually what I do is first try it without, and then if it just returns the data frame, I know it's returning the data frame and it's not saving it to the data frame. So when I see that, I generally add in place is true. Another way to go at it is to if you have just this command, you can also do Amsterdam is this, and then it saves this to the Amsterdam data frame. So, but I think comma in place is true is just very pretty because it gives you short codes. But you can always use the Amsterdam is and then the data frame you're returning. All right. So
sorry, Britt, Stephanie
yeah.
also has a question.
Oh, yeah, sure.
Yeah, I just have a question. What was the coordinates that was before? Because for me, it was confusing that they have different coordinates. So
Yeah.
what the format before?
What
What's the format before? What is the difference? Because what they have different coordinates.
Yeah. Well, this coordinate system, and I will get to it a little bit later, is a coordinate system that is specific to the Netherlands and that preserves the distances of the figures. So if we would have stayed with this coordinate reference system and we like took the length from the north of the figure to the south of the figure, that would have been the actual distance in kilometers from the north to the south.
Oh, I see.
So you have, I think you've all heard of the Mercator projection of the world. And it preserves the different sizes more, because I mean we have a round globe and we often want to view this as a 2D figure, and the question always arises, how do you show that shape in 2D? And there are different ways to do it. I mean, let's just look at Google Images at different projections of the Earth, and let's see if we can find different ones in images. Yeah, here we go. So this is the one that we all know, but generally Africa is not shown to be that large and Europe is shown to be relatively large. But if we would look at the globe, like Africa would be much larger than it is portrayed here. So then we have this different projection, which shows Africa to be much larger than Europe. And these different sizes are a bit more preserved. Like a coordinate reference system is kind of a way to project this 3D image into a 2D image. And there are all these different projections that really preserve the distances of the country you're looking at. I've also included it in the slides here a little later on a website where you can search for the different projections of different places. So like if we were to look for the Netherlands, Amsterdam, just the Netherlands, maybe. Here we go. Then we find this SPSG, which we've seen before of our of the Amsterdam municipality, right? So this kind of preserves that shape of the Netherlands and keeps these distances to true distances, if you understand what I'm hinting at. Is it a bit clear? I was gonna get into it a little later, but or show you how to work with that for distances of roads. But let's just first plot these two figures and see that they have the same CRS now and they translate to the same coordinate system. So here, this blue shape is the shape of Amsterdam, and we see all these different roads again with the column highway, and we see these coordinates that we've seen before. But it's very useful to have this Dutch CRS because this preserves these distances, which is very useful for example, the distances of roads. So say we want to know the kilometer lengths of these different roads, what we can then do is take this CRS again and then use geometry.length. So maybe I should explain that a little more. So if we look at the roads Amsterdam, we have this geometry thing, right? So let's look at that. So the geometry of the different lines. Now, if we do dot length, we get the Euclidean distance of these roads, but we see they are very short. And that's because we're just looking at the longitude and latitude, and they don't properly translate to the length of what it really is. So now we can change this CRS to be the CRS that we found here, so 28,992. And then I've made a little function here that doesn't reset the whole data frame to have that CRS, but just to create one column that uses that CRS to calculate the lengths. And then if we run this, we now see that we have here different lengths of the roads, and these are the true lengths of these roads. And then if we look at what the total amount of kilometers is, we just add them all together, and we found that there are more than 5,000 kilometers of roads in Amsterdam. And we can also plot a picture of Amsterdam with this length of the roads. And we see that, for example, this road is relatively long. So that's what we can, that's why it's useful sometimes to not use the most or the most common CRS, which is the ones that a lot of data is often provided in. Is that a bit clear? What you can use this for? All right. So in case you want to do this for yourself, I've made you this little function here, which is calculate the kilometers length of roads. And it's automatically put the coordinate reference system of the Netherlands. But if you would ever want to apply this to a different data set from a different country, you can search on this website, spsg.io, for the country you're looking at. And then just add here, lower bar EPSG is, and then the code of the coordinate reference system you want to translate it to. And it will return a column with the length, the kilometers of length for the country you're looking at. And then you can calculate the total amount or make a pretty plot. Is that clear?
Britt, Esme would like to ask, why did you decide to convert the Amsterdam DF to longitude latitude coordinates rather than convert roads_Amsterdam to the Dutch coordinate system?
We could have done both. That didn't really matter. I just wanted to show that if they have different CRSs, then you will get an image that looks super confusing because you're looking at different coordinates. And then if you convert them to the same one, and this 43261 is the one with longitude and latitude and therefore the most used, then you can plot them together into an image. We could have done it the other way around. It didn't, I mean, for this exercise, it didn't really matter.
Okay, thank you. And Martijn would like to know, what do you know, how do you know which coordinate system is the accurate one for your country?
Yeah, so what I usually do is calculate it or find it on this website. So it's included here. I've put it in this little text in the notebook, and at this website you can just search for it. And then sometimes you get multiple ones. Usually the first hit is the best one, but if you're a bit doubting, what I generally do is just look on Google Maps and kind of measure the distance. So just to show you how you could do that without spending too much time on it, you can do a right mouse click and you can do measure distance, and then you can go from, let's see how long the distance from Vester Park to the train station is. And it tells you 1.3 kilometers. And then you can look in your own map or the sizes you have, how that works. So, I mean, in our case, we would have look at Amsterdam. We get this figure, and then we do measure the distance maybe from the highest point. Oh, clear measurement. So measure distance from here to down here, and it's 11.9 kilometers. And then if we look at, let's see, so we have this Amsterdam one. It's now in our old, or in the like most used, the most commonly used CRS. But if we go to CRS and then use this one again, in place is true, and we look at Amsterdam geometry bounds, and then we subtract the max y from the min y. So we do this dot max y minus that thing dot min y, and it's giving it in meters, but here we divide this by 1,000. Okay, in this case we get 17, which is about, yeah, it's not exactly 11, but this is the best one we have. But I didn't actually play with this around in the beginning. I just took the first one. But in case you're doubting, you can kind of use these methods to see if the measurements really work. Also, it might just have gone from here, maybe from here to there or something like this. And then we get about 70 kilometers. Or at least this point. So that's kind of how I try to figure out. Is that clear? Okay, nice.
Well, yeah, it's like when I search on the website for the Netherlands, we get 200 results.
Mm-hmm. Yeah, so I usually take so if you go to the Netherlands, you do get 200 results. So that's why I usually test it a little bit. So, I mean, usually the first hit is the best one, but it can be a bit confusing. So you could try different ones. I mean, you can also look at the image here, and then you see that this is a CRS that also includes the United Kingdom. So it might be a little less accurate. As this one has an image pure focused on the Netherlands. And I mean, this one has the same. This one also just changed one. So it's probably very close to the CRS we're already using. But this is, in Dutch, we would say natte vingerwerk. So it's wet finger work. So you can't know this for sure. Like usually the first hit works, and if you're doubting, you can use this measurement technique on Google Maps to see. But then do make sure, because I just put the lowest one here, but of course this is going to be about the lowest coordinate, and then this is going to be about the highest coordinate, so you measure it properly like that. And then of course do it in the long way as well. So in this case, like this, and make sure that it's straight. So this is like 23 kilometers. And then here we do max x minus max y. And we get 23 kilometers, which is about the same as we had here. So that's usually how I go at it. Any more questions about this? I can understand that this might be a bit overwhelming. I see a thumbs, so let's just continue, and you can always send me an email if there are more questions about this, of course, because this is a bit of the more difficult part of it. All right. So we've calculated our length, we've summed up to see how many kilometers there are, and we've made a cute little plot. And now we move on to a different type of data, namely raster data. So a lot of data that comes from satellite imagery is often in a grid. And with a grid, I just mean like some rows and some columns, and each cell or each little square in this raster then has a value. And often population data comes as a raster data set. And that's what we're going to look at now. You can find more raster data. You can find more information about raster data in a beautiful blog that Parvati also made, that I now see that I use the archive link of. But here Parvati explains a little bit more, but we're going to do some of this today. All right, so let's first download it. And I think Parvati's talked to you about world pop data, right? In her last lecture. So the world population data. I see no nods. Is this completely new, or should I explain this a little bit more? Well, anyway, World Pop is a organization that collects world population data, and they have almost of every country a beautiful little raster data of the world population. So here I've made a way to download it. Again, it's where you find an URL that downloads the data for you here. And then this little code like prepares it to be a Rasterio item. So Rasterio is the Python package that I and Parvati as well use to work with this data. So in our case, we now have this NL pop thing. And let's just have a little look at NL pop. So we don't really get a lot of information from it, but we can, for example, get a CRS from it. And here we see it's using the most commonly used coordinate reference system, 4326. And now in the next figure, we'll be getting into the figure itself. So let's just run this first cells, just so you know what's going on. So we do read and then the first layer. And now we get a matrix kind of with a different value in every part of the matrix, as you can see here. And now we see all minus 9999, because if we look at the map of the Netherlands, which I'm going to plot here, using the next cell, we see that these, I mean, this cell refers to like this point here, this cell refers to this point here, etc., 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 and the information is more in the middle. So that's why you're getting all these 9999 values. But anyway, here we've just taken that matrix. We want to make a plot of it, so we set the figure size of the plot. We use plt.im show, and then we use only this layer with the matrix in it. And next we set a color bar with it, and then we get this image. So here, for the people that recognize it, we see the Netherlands, more or less. The values that are yellow are the ones with, it's a bit confusing because we have all these minus 99999 values. So these have become really dark. So these are the ones that are quite low. But the yellow areas are the areas where the population has the highest count. So this image kind of shows how this population is spread. Now, to take out these 9999 values and get a more accurate bar, we add NL pop dot clean is NL pop dot, and then NL pop dot is larger than 0. And then we should plot that. Oh jeetje. Zit NP where? Okay, it doesn't seem to be working the way I wanted it to work. I'm sorry about that. It is in Parvati. Well, it doesn't really matter. Because we're just going to look at the next cell and see how we calculate with it, and we could plot this a little later. So anyway, in this cell, we're taking all the parts where the total population is larger than 0, and we're going to sum those all together, and then see how many millions of people live in the Netherlands. Why we can't just sum the whole matrix together is because we have all these minus 9999 figures or cells, and if we add those all together, just to show you how that works, so NL pop tot sum, then we get like minus a lot. So that's why we have to filter out these values that are minus 999 to get the accurate amount of people. And we see, I mean, currently, I think in 2023, we are at 18 million people, but this data set is from 2020. And at that point, we were somewhere between 17 and 18 million. So this seems about accurate. Yeah, as I explain why you need to do NL tot is larger or equal than 0. All right, next, I've talked about this EPS or these CRSs again, and we see that it has the CRS that our Amsterdam network has as well, and that our NL bounds data frame has as well. So what I'm going to show you next is how you can extract information from this data for a geodata frame. So I have now written this function, and I think you don't need to explain. I don't need to explain exactly how it works, but you can just use it if you ever want to work with it. So, but what we're going to do is for every municipality in the Netherlands, we're going to calculate how many population are living in that municipality. And to do that, we use this get population count function that takes the vector polygons, so the polygon from the municipality we're looking at, and the raster layer, so the raster data. And because the NL pop tot is just a matrix, and we also need to know the CRS, we need to put our original object NL pop. That was the first thing that we saved, or the thing that we downloaded from WorldPop. So we use this function, and we do NL bounds, and then we look at the column geometry, and we apply the get population count, and we tell it that the raster layer is the NL pop. And then when we run it, we get a population count in our data frame. So here we have the data frame again, and now we have this new column with population count. So that's how we calculated that. And now we can plot this data again. So here we do dot plot, we use the column population count, and we want to have a legend. And then we get this image. And it's we see that especially a lot of people live here in Amsterdam again, and here in Rotterdam and The Hague and in Utrecht, and that for the rest the population is quite low. Now, I think for this part, it's not important to per se understand everything that's happening, but it's good to know that you can use this function in case you would want to extract this data from your data frame. Is that clear? And this blog that I've included from Parvati also shows you how to filter out the -9999 lines. So it's especially this part that for some reason wasn't working for me today. All right, so that is some information on raster data. And now the last thing I want to show you, or maybe it's nice to have a little break, or I'm not sure. Do we usually have a break, Kate?
For 2-hour sessions, no, but it's up to you. If you're feeling like you want a break, we can also do a break.
I'm okay without a break, but I thought maybe the participants would want one. But if it's not regular, I'll just move on to Folium.
Okay.
Okay. All right. So next we're going to work with Folium, and Folium is a completely different way to work with geographical information, because with the raster data and the GeoPandas, we downloaded these data sets and we were just using the information from the data sets. But sometimes you would maybe also just want to work with a map and get some information from the map. And that's where Folium is very useful. So here we do some of the inputs from Folium and Pandas and GeoPy again. And what I'm going to do is just make a little plot of Amsterdam. And it's just going to show me the map of Amsterdam, as you can see here. So there's no true need to understand what's going on here, except that this item L is kind of, it extracts it. So you tell it find Amsterdam, and then it will kind of find a latitude and longitude and some more information of Amsterdam. And then here we tell it the location that we've just found from this first line, and we decide what the zoom is. And we tell it that we want to use the OpenStreetMap, and then we just plot it here. And we can play around with this a little more. So let's say we want to look at New York. Then it will show us the map of New York. But we see that it's zoomed in a lot, so we can zoom out a little bit. So let's do maybe the zoom of 12. And then here we see New York. And then, of course, we can use this to zoom in and out. But that's how that works. So it's a very cool way to work with map information. So there's a little bit more we can do with this. Namely, we can combine this map with some of the GeoPandas data frames that we've looked at earlier. So again, there's no need for you to understand this function, but we had this function at geodata, and we first again make a map. So I've taken here the middle of the Netherlands, Utrecht, and then a zoom of 8. And we have then this folia map M, and I'm hearing some background noise. Can everybody please mute themselves? Thank you. Okay, so anyway, we have this map M again, and we want to add our boundaries. So the boundary data set that we had before. And of course, make sure that you're working with the regular coordinate reference system. So 4326. So anyway, we add this geodata to our map M, and we plot it. And then we can see again this map of the Netherlands with all these municipality boundaries again. Pretty cool, right? And we can use this function also to add the road data of Amsterdam. So I don't know why this is here, but anyway, we find the place we want to look at. So we're going to look at Amsterdam in this case, because it's just the road network of Amsterdam. We make our map. We add to our map our road data. And in this case, I just wanted to look at like the more primary roads, because when I tried plotting this with all the road data, it took quite a while. And I just wanted to show you how it works. So we're just looking at the highway types that are tertiary, secondary, motorway or motorway link, secondary link, primary link, busways, and tertiary link. And as you can see, it already takes a little bit to make this map. I hope it won't take too long. And here we see again Amsterdam and a bit of the road network that we were looking at before. So this is another geo data frame that we can add to our Folium map. Pretty cool, right? But now this was just looking at the Folium map and some information that we already had. But we can also use Folium and GeoPy to extract information within our notebook. So in this case, we're going to place some markers on some cool places in the Netherlands that are nice to visit. First, we're going to make a pandas data frame with the information that we want to have, and especially the latitude and the longitude and the color of the marker we want. And then later we're going to plot that. So I've made a little function here that uses GeoPy and that locates a certain place. So we want a description and a locator. A locator is often the city or something that it is in. And then here I've made the function create a location data frame. You don't really need to understand these two functions, but what you do need to understand is how you make the data. And in this case, we want to make a dictionary. You've seen that before, right? And we're going to make a dictionary that has the address or the name of the place, the city it is in, and the color of the marker we want. So I've just taken some random places that I thought are nice. So we're going to look at the University of Amsterdam, which is where I am now. We're going to look at the Spoorweg Museum, so the train museum. We're going to look at the Efteling, which is our big amusement park. We're going to look at the National Park Hoge Veluwe, which is just a very pretty national park, and at the Keukenhof, which is where a lot of tulips are grown. These are located respectively in the cities Amsterdam, Utrecht, Kaatsheuvel, Ede, and Lisse. And the markers that I want are respectively blue, black, green, red, and purple. So I use this function create location data frame, and I'm going to input this dictionary into it. And then when I run it, I get the address or the name, the city, the color, the country it is in, and the latitude and the longitude. And now I'm gonna mark these locations. And I think most of what you need to copy, you don't need to understand it, but we again make like where we want to focus on. So that's that first line, that's this L that we've been looking at in other cases. So this GeoPy, that blah, 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 and then the geocode of the place we want to look at. So in this case, we look at all of the Netherlands. We make a new map, and we give it the central location we want to look at. And we this time I took the zoom of 8. And then for our different things in our data frame, we're just going to use this function. And all you need to know is that you copy df into it. This is the one that this is the data frame that you made. So that needs to go here, and you add the name of the map. In this case, I've named it map. And when we plot this, we get these little markers on it with the name if we go onto it. So here the pink one is the Keukenhof, the University of Amsterdam, Spoorweg Museum, and het Hoge Veluwe Park, and the Efteling. And that's how we add GeoPy information into our Folium map. And I think actually that's what I wanted to teach you. I went through it a little faster than I was expecting. But this is just some way to work with geospatial data. Are there any questions? Martine, go ahead.
Yeah, so maybe then about the last function for the create location data frame. Maybe you can explain a bit like how do you join that information? Because you made this data frame with just writing University of Amsterdam, but how would I know which, I don't know, like what information is available?
Well, usually it returns nonce if it's not there.
Or
So
how
I mean, we
I
can just try this again
I have to
and make a new one, and let's just put something in there that doesn't exist. So we'll keep University of Amsterdam, but
write
let's
Spoorweg Museum. Like, how do you know?
well, you just have to run it. So let's say I misspell Spoorweg Museum and I do Speurweg Museum. Then it will not be able to find it unless it's something really weird that existed. And I keep all the information, all the other information as it is. And now we see here that it wasn't able to find the Speurweg Museum because it has a non-value in there. And then if we try to plot this here, then we get an error because it contains nonce, and that doesn't exist in the longitude and latitude. So that's kind of how you know. And what you can also do if you want to search for something, but of course that is the other way around. I mean, if we look here, we could already find like this has the marker Efteling. And let's see, what I also wanted to do is add another one that had het Wat, because I think het Wat in the Netherlands is also beautiful. But I couldn't really find something here that said het Wat properly, and that was in a clear city. So that's also why I didn't add that. So
Okay, but in general, you can an address like a street name and a house number, and then it can find it, or just like known places.
Yeah, you can also do that. I mean, that's information that's in there. I'm not sure if house numbers always work, but wait, if we go to like Amsterdam, then it usually has the numbers of the houses as well. So if we do Keizersgracht 620, and let's add that here. So we do Keizersgracht 620 in Amsterdam, and we run that again, and we see it has now found the latitude and longitude of it, and then we can run it here again, and then it'll plot it on there. So now we have these two markers in Amsterdam.
Okay, thanks.
You're welcome.
Esme would like to know, why do you need to add the city of the DF data frame? Are places only unique within a city?
Not per se, but it's easier to find it. And I think that's just how I made the function here, because when you do search for it here in the function, it sometimes uses the city. I mean, we have the function locate geopy, and you just have the description. That's what so the city is the locator. I think if I would have wanted to do, we can have a go at trying to find het Friese Wat, so Friese Wat, and let me just check if it exists in the map like that, if that is the proper name for it. It's up here. Yeah, so it's Friese Wat, and then I just add Friesland here, and let's see if we can just find it, even though Friesland is not a city. Yeah, it was able to find it. So now I have the coordinates and I can map those. And you will see it's over here. So it doesn't only need to be a city, it's more of like that it knows kind of the location to look for. That will make it a bit easier for it. But as we've seen before, because the locate geopy function in some way makes use of the geocode, which is also what it's somewhat of what we've been using here. So here we used Amsterdam and then we just gave Amsterdam, but in this case we could have also done University of Amsterdam, and then it just plots the map around that.
Okay, mine is a quick one. I come from Kenya, where now we have the pastoralists who are in those they move with their livestock. Is there a way we can use the same to map the geolocation where we have the water catchment, where we have the water sources for their livestock, using the same approach?
That depends if it is in are we talking about still this Folium, this making a map, or are you talking about other types of data?
Yeah, using this same Folium.
That depends if it is on the map. So I mean, you can always give it a try and see how to write it. I don't know. And if it's data like water catchment, I mean, it's just looking at locations that are located on the map. So I don't think you will be able to find like water catchment areas, but maybe I misunderstood your question a little bit.
Like what I meant is there are some specific locations where maybe the pastors don't have a know-how where we have the water sources. So if we can use this Folium to trace those water sources for their livestock.
Yeah, I think I don't know for sure. It depends on if it's on the map. So I think first you will need to check if you can find one example maybe on the map. And then you can check if it works. I hope that answers your question. I'm not sure about it.
Yeah, it's okay. So I can give a try.
Okay.
Valeria would like to ask, can you use the same functions to label multiple locations, for example, parking lots?
No, you will need to locate the exact parking lot because it returns to you this latitude and longitude. I mean, you give it a name, it searches it on the map, and then it will not be able to tell you if there are like multiple different parking lots. It needs to find one specific place. But I think if you type in parking lot Amsterdam, it might just find one random one. And maybe if you do parking lot and then change the little locator, so what I've named city here to New West in the case of Amsterdam, like just one little part of Amsterdam, then you might be able to find different ones. I haven't tried that out.
Okay. Yamin would like to say, just curious, Looker Studio is easy enough to do the capabilities. Are there distinct differences between them?
I've never worked with that, to be honest. So I don't know. I mean, there's a lot of Python software working with geographical information. So there must be some pros and some cons on the different ones. But I have never worked with that one.
Okay. And there's also a question between the difference between working with GeoPandas or geocoding as opposed to working with GIS software.
Well, GeoPandas is a type of GIS software. So what you can also do is download your GeoPandas data frames into a program like QGIS and then work from there. But the nice thing about using GeoPandas in Python is that it's in Python and you just immediately can start downloading. At the beginning of Analytics for a Better World, we worked with QGIS, and then we, for example, would calculate in QGIS the distances of the roads and then download that information into Python. But it's much easier to do that all together in one software set, because then you don't need to change around from programs, and if you don't have it on your computer, you don't have to worry about it. So that's, I think, an advantage of it. But GeoPandas is a part of GIS software.
Great, thanks. Stephanie says I was trying to do the first exercise with Den Haag, but I couldn't find it in the NL_bounds data frame. Does it have a different name?
Sorry, what are you looking for in the
first exercise? She tried to do it with Den Haag, but she couldn't find it in NL_bounds data frame.
It might be Schavenhagen in this case. So I think I can do it with you. So let's do, and then you do site to get the apostrophe. Schavenhagen. I've accidentally saved that to Amsterdam. Okay, so couldn't find that. Den Haag. Maybe, but what we can then, if you can find it, what we can try is I think string that contains, and then maybe put Haag in there, something like this, and then we do NL bounds. I mean, it should be in there something. I think just the gemeentnaam is difficult. What you can also do is look for the code of Den Haag. So Den Haag telefooncode, it's 070. So then we do code is 070. It should be a string then, I think. Oh, this is strange. I can't find it. But if we look on the map that it's plotted, then let's look at it here. It does have Den Haag here, so it should be in there under some name. Yeah, so what we could do is try to get the coordinates of the, I mean, this is a bit more technical, I guess, because we can use Folium or GeoPy to get coordinates of Den Haag and then make a point and then search for locations that contain that point. So I'll just do it, I think. So let me see where it's just playing around. It is, it's here. So then we do Den Haag, and then we make a point. And I'm not sure if I've imported that yet, but we can do L.latitude, L.longitude. I also never know if I'm using latitude and longitude the other way around. But anyway, then we do nlbounds.geometry.contains, and then we do point Den Haag. The name point is not defined, so we need to import that from Shapely. So from Shapely, import point, and I think it's Shapely.ops, if I'm not mistaken. Yeah. And now we can do NL bounds. Still didn't find it. Or I did latitude and longitude the other way around. Yeah, here. This is why we couldn't find it. It is apostrophe F and then a dash. Gravenhage. So now we found Den Haag. So we can have a look at NL bounds.location, and then we do to the index, so it's 231, and then we do geometry, and now we get the little shape of Den Haag. Here we go. This might be a little much. I mean, there's a lot to play with when it comes to Shapely. I think it took me like a month or 3 to like get used to it. Yeah, I mean, this geometry is based on the Shapely package, and Shapely works with these line strings and polygons and points and things like that. And you can just test if a geometry contains a certain point.
Wait.
Yes, sorry. Did somebody say my name?
No, but there is a question in the chat. Shola would like to ask, what documentation would you recommend for further reading? Or for
About-
beginners in this field about geomaps?
About geomaps, there's a lot of information about geomaps. Like for the work that I've done, I've mostly worked with GeoPandas, and I mean, I think it's also I think what you start with that you get used to, and then you translate it to. So there's some other packages, and I have some colleagues that use different packages. But I generally try to translate everything to GeoPandas or raster data, just because I'm used to working with that. And I think it's also, you just find what, I mean, it's just a project you were on that is most useful and that you know how to work with, right? So I think GeoPandas is most commonly used, and raster data, and there are also ways to translate raster data to GeoPandas. And in that case, I would just, I guess, start doing a lot of exercises. I actually don't know where you can read up on it. I know Parvati has a few very nice blogs on working with geospatial data. So I think you can have a look there. And I would just start working with this data, and then Google and read through the documentation of GeoPandas to see what you can find. I hope that answers your question. I actually never really took any courses in this, and just tried to teach myself and play around with it a little bit.
Thanks, Britt. Amen would like to ask, before you close the session, would it be possible to just do a quick recap of what you've gone through today?
Oh, of course. Yeah, of course. So we first had a look at GeoPandas. We looked at how these data frames look, and what this geometry column means. We practiced how to plot it, and that you can play with different column values, and how to work with information that is missing in your data frame. Different ways to deal with that. We've looked at CRS, and how CRS works, and how it influences your plotting, and also that different CRSs can be useful for proper projections and calculating the distances of roads. That was it, I think, for GeoPandas. Then we looked at raster data. We looked at how to plot it, and how to do calculations with it, and how to get information into a GeoPandas data frame from raster data. And then last we looked a little bit at Folium and how to plot a map using Folium, how to combine GeoPandas information with Folium, and lastly, how to use Folium to find markers on your map in the first place. I think that was it.
Okay. Thank you, Britt. Did you have anything else you wanted to cover today?
No, this was actually it. I
Okay.
went through it a bit faster than I thought.
That's fine. I just want to close by saying, and thank you so much, Britt, on behalf of the ABW team. We really appreciate you giving the session today. For everyone online, please remember to fill in the survey. The link is in the chat. Also, the link for the Google Colab that we went through today is on Slack. And it's also been brought to my attention that there was an outdated calendar out there. So please note that the session tomorrow starts at 14:30. So 30 minutes later than today, and it will go till 5 o'clock. So you can see the updated calendar also in the Slack channel. And if you have any questions for Britt after today, she's also in Slack, so feel free to post those in there. That's it then. We'll see you guys tomorrow. Have a great rest of the day.